Let's talk about something most of us, well, overlook. Think about when you walk into a huge industrial space, maybe a warehouse club, a factory floor. Your eyes usually go straight to what's happening down low, right? The shelves, the machines. But what if you actually force yourself to look up that ceiling area? Often it just seems like, I don't know, visual noise. Or maybe just boring and functional.
Yeah, functional is the word, but boring, I think not. It's kind of like the building's hidden nervous system. And that's exactly why we're doing this deep dive. We've been looking closely at photos, notes, really digging into industrial ceilings. Our goal here is to figure out what's going on in what looks like just a tangle of pipes and beams up there. There's actually some really clever structural stuff happening.
Right. Because the big reveal, the thing that jumped out at us, is that this isn't simply a roof sitting on some beams. It's a whole system, all planned out, where the structure itself, the skeleton and all the vital services like air, power, fire safety, they're deliberately woven together. The key thing is that the structure is designed to let all that infrastructure pass right through it, not just hang underneath it awkwardly.
Exactly. And once you grasp that, suddenly that messy-looking ceiling becomes this almost transparent diagram of what the engineers cared about most. It's pure function driving the form or, the lack of obvious aesthetic form. Efficiency over everything.
Okay, let's break it down. Starting with the absolute basics, the main skeleton holding everything up. Before we get into the finer details higher up, you need that massive primary frame, right? For a building this size, you've got to have serious strength just holding the roof overhead.
Absolutely. And that brute strength typically comes from concrete. We're talking about the core support system. It has to handle the huge weight of the roof itself, plus snow, wind, you name it. So the main vertical supports, usually these really beefy concrete columns, they take all that compression force straight down to the foundations.
Okay, columns going up and then lying across the tops of those columns, spanning the whole width.
More concrete, huge concrete beams. Those are your primary horizontal pieces doing the heavy lifting, covering those really wide spans you always see in places like warehouses or factories.
But hang on, if you've got these massive concrete beams, why do we often see steel beams sort of layered on top of them? Seems like overkill.
Ah, that's a great question. It gets into the trade-offs in structural design. Concrete is fantastic in compression, right? It's got sheer mass. But over really long spans, it can be susceptible to, well, bending tension. So to add extra stability, maybe handle vibrations better, or even seismic considerations, engineers often add steel beams right on top of the concrete ones. It's like layered protection. Concrete for bulk strength, steel for better tension handling and spanning capability. It gives you that extra margin of safety and performance.
Got it. So it's like combining, I don't know, the raw power of the concrete with the sort of tensile strength and reach of the steel.
That's a pretty good way to put it, yeah. The concrete takes a big squeeze, the steel handles the stretch and helps bridge the gap.
Okay, so that's the primary skeleton, concrete columns, concrete beams, often topped with steel for reinforcement. Now, let's move upwards from that heavy frame to the system that actually supports the roof panels themselves. This is where things get maybe a bit more intricate, less about brute force.
Definitely. More about efficiency and integration. When you look up from the floor, the most obvious thing you see below the actual roof surface is usually this network of steel. It's typically an open web steel system, sometimes called trusses, sometimes purlins, depends a bit on the scale and how they're used. But their job is the same. Hold up the roof materials, but do it in a way that leaves space usable.
And open web, that's the crucial phrase here, isn't it? Can you unpack that? It's not like a solid steel I-beam.
Right, exactly. An open web truss or joist looks more like a lattice. It has a top chord, a steel element running along the top and a bottom chord. But the space between those top and bottom chords isn't solid metal. It's crisscrossed with smaller steel members, leaving lots of open space. Think of it like a long, strong, triangular ladder lying on its side.
Okay, so it's strong but lightweight. But the real reason for that open design
is pure functional necessity. That's the insight we mentioned earlier. The openness is completely intentional. It's designed specifically to solve that big problem. Where do you run all the building's arteries, the ducts, the wires, the pipes? If you hang everything below solid beams, you lose headroom, it looks messy, and maintenance is potentially a nightmare.
So instead of having everything dangling down, getting in the way, you literally thread it through the structure itself. It's like the structure is saying, come on in, utilities, there's space for you right here. It's like, the mess of wires behind your TV. Right. This is the super organized industrial scale version of tidying that up by building the organizers right into the supports.
That's a perfect way to think about it. And it makes maintenance so much easier down the line. Need to add a new data line, fix a leaky
Yeah.
pipe, upgrade the HVAC. It's all running neatly within the designated pathways inside the structure.
Hmm.
The kinds of things you see in there, well, big air ducts are common, obviously. Bundles of electrical conduit, plumbing lines for water or drainage.
And the one example that always seems to stand out because it's often brightly colored.
The fire sprinkler system.
Yeah.
Absolutely. You can often trace those distinctive red pipes, that's the standard color, weaving their way directly through the open webs of the steel trusses. Seeing that essential safety system physically integrated into the structural members, that really drives home this whole philosophy. It's function dictating form.
It really shows how the building's skeleton and its operational systems have to work together, completely intertwined in these industrial settings.
They're inseparable. One can't really function effectively without the other being designed in concert.
Okay, so we've got the primary concrete and steel frame, then the open web steel system holding the roof and integrating the utilities. What's next as we move up? We must be getting close to the actual roof surface.
We are. Attached directly to that steel framing, often on the underside, you'll see the next layer. This is about controlling the environment inside.
Insulation.
Exactly. Yeah. Insulation. You often see it as this shiny, reflective foil-faced material, or sometimes a white vinyl facing. Its main job, obviously, is thermal control, producing heat gain in summer, heat loss in winter. Critical for energy efficiency, even in a minimally conditioned space like a warehouse.
But that layer often does double duty, doesn't it? Especially in these big, cavernous buildings where you might get significant temperature differences between inside and outside.
Yes, absolute crucial secondary role.
Yeah.
It often acts as a vapor barrier. Think about it, you have a huge volume of potentially warm, maybe humid indoor air. If that air hits a cold roof structure, especially metal decking, you get condensation, potentially lots of condensation. And that leads to rust, mold, damage to insulation, drips. Big problems. So that foil or vinyl facing isn't just for looks or reflecting heat. It stops water vapor from reaching the colder structural parts.
Right, so it's managing both temperature and moisture. Two birds, one stone. Or one layer, rather.
Precisely. Temperature regulation and moisture management in one go. Very common and very important in these types of constructions.
Okay, we're almost there. We've got the heavy skeleton, the clever open web steel, the utilities running through it, the insulation vapor barrier below it. What's the very last structural piece on top, the bit we can't actually see from the floor?
That would be the roof decking itself. This rests directly on top of the open web steel trusses, or purlins. It provides the solid surface, the substrate that the actual weatherproof roofing membrane, like TPO, EPDM, or built-up roofing, gets attached to. In the examples we looked at, this decking was typically corrugated metal sheeting. Strong, relatively light, spans well between the steel supports. So yeah, while you don't see it from below, it's the final piece connecting the structure to the exterior skin.
Wow. Okay, so we started this looking up at what seems like maybe just an afterthought, a ceiling full of stuff, and we've ended up realizing it's this incredibly layered, highly engineered system. Everything from those massive concrete columns at the base, all the way up through the integrated steel, the utilities like those red sprinkler pipes running through the structure, the insulation. It all has a very specific, very functional purpose. It's all about efficiency.
It really is. It's a masterclass in function-driven design, almost engineering honesty, you could say. What really strikes me, and maybe strikes you listening, is how aesthetics are just, not the primary driver here at all. Efficiency, cost, maintainability, structural integrity, those clearly came first. They didn't try to hide the guts of the building. They made the structure accommodate them openly. And like you said, that knowledge, that appreciation, it's just hidden in plain sight until you decide to really look up and understand what you're seeing.
Which brings us to our final thought for you to chew on. If systems this complex, this vital for load bearing, for safety, for keeping the environment stable, if these systems are so routinely overlooked in the huge buildings we use every single day, what other giant essential pieces of engineering might we be missing? What other complex designs are hiding right above us or around us just because we haven't shifted our perspective? Maybe next time you're in one of those big box stores or warehouses, take a second, look up, see what you can decode.